Yeah.
Morning. So today is day 2. We are continuing with our training on HVAC system BIM design using Revit MEP 25. Okay, so today we are going to check how to place air handling units. So let's get a few overview on what is air handling unit. So air handling unit and B is a device used to condition, circulate, modify the characteristics of air through the process such as filtration, heating, cooling, humidifying, dehumidification. So a standard air handling unit is basically around the packed units. So all of this process equipment for filtration, heating, cooling, humidification, and the dehumidification are packed in one unit. Also, there is a custom building of air handling unit, depending on the required function. For example, you can add heat recovery devices. You can add the economizer. You can add a smoke exhaust. That we are customized first to enhance energy efficiency or safety. So this is typically picture of air handling unit. You can see here we have fan here with filters. Here we have refrigerant pipe which will supply the refrigerant to the coil, depending each coil, heating coil or cooling coil. So here is a multiple section inside the air handling unit. This is different type of equipment arranged packed in one unit. So the first one we have, this is air inlet louver. Air inlet louver. You can see here we have opening. This one can help in opening and closing this air inlet. After air inlet louver, we have filter. Here we have air filter. You know, the outside air contains some dust, so the air need to be filtered for safety purposes. After that, we have heat. The air is very moist and be preheated. After that, we have a cooling coil. So this cooling coil during the hot season or summer, this cooling coil can be supplied with cold water. Then the water circulates inside the small tubes. This one through the fins. Then the air is blown and be blown here or drawn through, supplied to the room. So after that we have heating coil. Heating coil during the cold season in the winter. Heating coil can be supplied with hot water here. Hot water coming inside in the upper pipe, circulating through these tubes. Then air blows, and we get the warmer air in the space. After that, we have a blower connected with a humidifier in order to control the amount of humidity in the room. So the last two here we have middle here we have a centrifugal fan. Centrifugal fan is used to create the air. Then we have fan filter. So fan filter are used to filter the air to get a good air. Fine filter. Fine. Yes. Fine filter. So in here in the heating coil can be supplied hot water from electric heater or from a boiler. So you can use any of that, or in the cooling coil can get cool water from chiller. So basically, we have two configuration for the air handling units. The first one is draw-through type. This is a configuration of a fan. How the fan is arranged. So in a draw-through type, and I can show you how draw-through type works. So in the draw-through type, the centrifugal fan draw the air from the back. The centrifugal fan is located on the front, so it draws the air from the inlet louver from the back. So air coming, the fan is the front, so the air draw air from the back to the front. As you can see here, the location of the fan is here. But from the blow through, the fan is front of the cooling coil or heating coil. The fan is the front. On the first one, which I said blow through, the cooling coil is in the back. So on this type of blow through type, its design can be vertical or horizontal. So they say that the fan pulls air through the air filter and cooling coil before discharging into the ductwork. So in this configuration, section before the fan has negative pressure. So this section here before the fan have negative pressure for this design for blow through coil. So the second configuration is blow through type. So this blow through type, the fan blows the air through mixing box, filter, and cooling coil before discharging to the duct. So you can see in the blow through here, the fan is behind the cooling coil. So this is the section has a positive pressure. Section after the fan here becoming a positive pressure. This design is normally horizontal. So in a blow through, it's only horizontal. But in a blow through, you can get two types: vertical and horizontal types of air handling unit. So this is a configuration of the fan, which usually in HVAC system, especially in air handling unit. You see here, this is exploded view of the fan, of this centrifugal fan. We have inlet, we have this bearing support, we have a blade, the impeller wheel. This is a frame, so the fan rotates and draw air through the side, supply air to this outlet. Discharged to this outlet. So we go back to Revit and see how we can can post it. We can make this air handling unit. So we are continuing with our model from the day one. When you go here, the small icon, 3D icon of the house, we can go to 3D view. So we can position our air handling unit on the rooftop. So on your model, we can see the level from level 6, 7 to the rooftop. So we go back to systems, the mechanical equipment is where we can find the air handling unit. Go under system tab, go to mechanical, then mechanical equipment. So you can see here we have air handling unit. Split system is vertical. So you can select it. Maybe you can select one of which. Then you can come and place it. Before placing it, you can change it direction by pressing the space button. If you press the space button, it changes direction. So, for example, we can place it. Let's place it at this outside here. So you can place them as many as you wish, depending on the capacity of the completed load capacity of the occupants, the space. So let's go to section view to see how the air is our air unit is arranged. So here you can go to view, then section, draw section here. You can see our section is looking on the opposite direction. Change it to the look on the another direction. Just click flip section, or you can right click the go to flip section option. So we increasing our view, our range, section range. For that we go to view this section. So you can see this is our air handling unit. As you can see now, it's on level 1. So we can place it on the upper level. You can select it, drag it, or you can use the upward on your keyboard. Let's extend this is our section view. view range. We can hold it and place it. Hold it and place it on upward. So we can view it from the top. We can now open this level 7. Open level 7 to see how is it arranged on the top of level 7. So basically, on our model, you can see here, if you click level 1, you can see here, you can select level 1. When you click level 2, you can select it, but when you click level 3, it's not selectable. You can see level 3 is not selectable on your model. Also level 4 not selectable. So how to go to each level? So if you want to go to another level, you just click any level 1 or level 2. Just right click, then go to create similar. For that, let's create the multiple level. So you can create maybe this one. This is for to view level 3. We click another one. View maybe level 4. We click another one. Same as these models. You can click up to level 7. So after clicking it, escape one time. Then we want to align our levels with this model level. So just click any of the level. Then after that, go to modify tab, and there's this icon which is called align. Then click align one time. Then come to your model, select level 7, then select again another level. So you can see we align this level to another level. So you can do for all level. First the original destination, then you click second for it to move, be aligned. So we can do it for remaining levels. This is a level 3. Then after if you finish it, escape one time. Then go to view. View tab, then click plan views, then go to floor plans. After going to floor plans, here there's a button to show do not duplicate existing view. You can see here we have from level 3 to 8. So untick this. You can have all levels. So after that, select levels and select OK. So you can see here on when you come to project tree browser, when you come to project browser, you can see now under floor plan we have from 2 levels. Now we have like 7 levels. You can rename it. You can rename it as you like. So we just increase the levels because at the previous we had only 2 levels. So to view the upper floor in our model, because our model has many levels, we have to follow that step. So after that, we come our level 7. Right click level 7, then go to floor plan. So it will open. This is a level 7, our rooftop. So basically, we can drag and drop this our air handling unit to the position we want. Maybe let's place here. You go to this section view. Let's view it in our section view and see how it is on the section view. So this is a vertical type air handling unit. So also this one can be precisely on another level, maybe because this one is a vertical. And draw the ducts vertical. The duct outlet can come out vertically. So after drawing this, after placing this air handling unit, let's draw the ducts from this air handling unit. So just select it. Just go to section view. You can select it. As you can see, when you select it, multiple connection will show up. This one with a cross, it is a supply air system duct, and this one downward, which with the only diagonal cross, the return air. So how to draw the duct? You can just click this one. Then you can come here. You can see the system here is already classified as return air. So you change the width of the duct. For example, maybe 20 inches or 30 inches. After that, you draw the duct. So let's go to 3D view and see how does it look like. So you can see here handling units with the duct. You want the duct to go inside the building. They make it supply air to the maybe this the one floor beneath it, under it. Let's create another section here. go to view tabs and section, draw section, and go to view. So you can see here, go downward here, and let's make this only show lines. So make go to this down here, detail level, and select fine. So let's edit this. We draw and select it to draw product. Select, right click, then go to draw duct. Let's make draw size. So we came here and we can move over the ducts. You see, you can go around maybe 8 floors. Make it, you can draw it, make it around maybe up to the second floor. So that you can here make count again to system duct. Create another branch here for go to each floor. So you can go to 3D view to see how it is arranged. So this is how to configuring the duct. They are creating figuring the air handling unit and creating the ducts depending on your model. Hello, visual participant. Give me some minutes. I'm going to assist you here. Something. Hello, Mr. Mubarak.
Hello, good morning. Good morning, Engineer Chelsea. Good morning. Yeah, hello, good morning. Good morning.
Hello, Mr. Mubarak.
Good morning. Good morning, sir.
Hello. Yes, yes, Mr. Mubarak. We're checking about air handling units. So air handling unit.
Hello, sir.
So we were talking about air handling units. In a short form, it's AHU. So there's a central heating and cooling system. Use air handling unit and ductwork to distribute air to every corner of the building. So air handling unit. So we are going now to define what is family in Revit. So Revit family are the building blocks of Revit model. So we have the following types of Revit family. This one is the system families. These system families are the one which come with Revit software by default. So let's go back to Revit. Maybe let's go to this floor plan 1. So we come to system tab. Then we come to mechanical. Here on the properties, you can see all here are actually families. All this one are called families. So you can see here is there are handling unit families. We have 1, 2, 3, 4. 4 families here. Here we have a boiler family. Here we have a circulator family. Down here we have ironic tube families. Here we have a VAV unit family. So all of these are called families, but are on system families because by default they are in Revit software. So all of these are called system families. So starting from family is where we can start creating our systems. For example, when I select, let's say I select the air handling unit family. When I select it, you can see when you just select it, you can see place your cursor to the working worksheet. You can see here you already selected, the family is selected. So when you want to move it, rotate it, just on your keyboard, on your computer keyboard, type space. When you type space, you can rotate family to the different direction. So on the family is where we started to draw. For example, this is a hair handling unit. So on the hair handling unit family is where we start to draw our duct routing. So for example, we can place, when you left click, you can place it many times as you wish. For example, here we place 4 hair handling unit for demonstration. So if you want to escape to remove the command, so escape 2 times, the command will be removed. So when you click it on your family, is where you have the connection start from. So for example, this family have 3 types. You have 4. I have 1, 2, 3, 4, 5, 6 type of connections. So on this family, you can see here we have a create pipe. Here you can create pipe which will supply water to the cooling coil or heating coil. This is a family for hair handling unit. So on here, there's an electrical connector. Here you can see for supplying electricity to the hair handling unit. And here also is a pipe, but this one is a outlet. You can see here it is written out, which when the water entering the cooling coil or heating coil, will get escape from this pipe. This one is inlet. So one is inlet, one is outlet. So here in the duct also you can see we have 2 connectors. One is for supply air, this one is for supply air, and this one is for exhaust air. So on the family, it is where you are starting to create your system. So it is a building block of the model, because it's where all the system can start to be created. So for example, here let's draw a section view in order to see this handling unit. So let's go to view, up, then select let's go to view tab, then select section, then create a section for this AHUs, then open this section, right click, go to view, or you can just double click, or you can just double click it, will open the view. You can just double click, it opens the view. So as you can see from here, then we can start drawing duct. Just click this, you can right click this item here, press your cursor and then right click. There's some option here, you can draw duct. So here you can change the size of the duct. So let's go change this detail to, let's change the detail to fine. So in order to view the more. So you click this your hair handle unit. You will see different type of connection. Here we have duct, supply air. We have duct, return air. This is return air. Here we have connection for pipes. Here we have connection for electricity. So if you want to create the supply air, just right click on this one, then product. Then you can now when you click the option, you can just start drawing the ducts as like this one. So you can just place in the ducts layout. If you want to draw it again on the return side, just go this this mark, right click, draw duct. So here you see the duct that is very big. You can here come and change the size, and come and change the size. So let's move it upward in order for us to draw the downward duct. Move it upward. So just click. You can also click this elbow. Then on your keyboard, move up. Then you click this HU. Then you move up. So this is a vertical air handling unit. The orientation is a vertical. So if you want to draw a downward duct, just come here, then draw duct. Then you can select the size. Okay, so let's go to another section to see how to do this. Let's go to see here on another section. Go view section. Let's see it from this side. You can see it is resting on level 1. So from here you can also do the pipe which will supply the water to the coil. So you can see the outlet duct for this air handling unit is outlet is horizontal, and inlet for supplying air is vertical. So if you want to draw here duct, just click here, draw duct. Then you can come horizontal here. Let's size it maybe 12 or 20 by 22. So when you come here outside, let's increase this proper region. If you want to extend, draw another section, just click this small section duct. Then on the end section there is this mark with cross. Right click, draw duct. Again, you can continuing to draw again to other section. Let's move this this section view. So basically from the family is where they are building. It is a building block of our model. So I can see we start doing the ducts starting from the family. So the families which are coming with our software, it is called system families. So how you can also customize this? You can also customize this system family. You can edit it. You can customize it the way you want. For example, let's try to customize this system family. So if you want to customize this system family, just click it, left click it, then you go to edit family. When you go to edit family, it will open the individual Revit duct. So here we can customize the way we want. For example, we want to change maybe this outlet. Here we see the outlet is on downward. You can, if you want to customize it, to put it is on the side part. So if you want to put it down, just click edit, then it will open like this one. You come to customize it. So you click it, as you can see here, you can increase it. You can increase its size or decrease its size, but it is locally on the work plane. So for now, you can edit these connectors. For example, to create another connectors, just click this model, then you come here to create. Create tab. On the create tab here, on connectors, we have different connectors. For example, we have a pipe connector, we have keyboard tray connector, we have conduit connector, we have duct connector, and we have electrical connectors. You can modify this connector. You can come here and change the for now it is a rectangular duct. When you come here and change, you can change it to round. So it will change here. When you import it, it will draw the round duct by default. So let's try to change it round duct. So you only click that, then you come to properties and change the shape from rectangular to round. Also, you can change its classification. We have a supply air, return air, exhaust air, or others. So also you can change these connectors. You can change it to maybe if it is outlet or inlet. So here and the flow direction, you can change the direction of the flow. For example, if it is a supply air, you can click it out. Or for example, it is exhaust, you can click it out. For example, air from outdoor to air handle unit, flow direction, you can click it in. So here we can customize depending on the flow direction of the connector. For example, if we have a connector to the coil, cooling coil or heating coil. So for example, we can select one to be supplying water to the cooling coil, and the another one to get water from the cooling coil. For example, this one upward connector, select it, go to properties, and here on the flow direction, this one is inlet, this one is upward, so it will let water inside the cooling coil or heating coil. So here in the flow direction, click in. Now we define the flow direction. Click in, hit apply. Also, when you come to the lower pipe, you can edit it. You can edit the system classification. You can put hydraulic return. Hydraulic return, it is used to remove the water from the cooling coil. If it supply water to the cooling coil, we select hydraulic supply. So when you done editing, you just click load into project, or load into project and close. When you click load it into project, the close, this one, it will load to the project and close this tab, editing tab. So for example, if you click load into project and close, so save the changes. Yes, you can name it maybe air handle it vertical, and name is customized. Let's maybe put it on the desktop. Then here on option, put one backup. Hit OK, then save. So after saving, it will open. It will load into the a project which we were working before. So you can see here, already save it as here handle it customized. So it appeared on our list. If you want, we wanted to set it, you just come and select. Just come to our flow and select systems. Then we go to mechanical equipment. Then we find it here on the list. It's listed here. Here handling system vertical customized. So we select, for example, you can select it here. As now you can see we have two. This one was before it was a default, and this one is the one we edited and customized. So you can see now we have two types of air handling unit. So you can go and click, and you can select it one. Then also you can place it. Let's place it, for example. Let's place it, for example, here to see how to work with it. So let's here draw the duct from our customized family, Revit family. As you see, it starts to draw around the ducts, because when we are setting this our setting connector, we put it around the duct connector. So as you can see, how by default it starts to draw down ducts. So if you click here and then draw duct, it will come outside will come there around the duct, and here you can change the size from 390. So that is how to edit, to manage and edit parameters in the family. So for now, let's creating our custom let's creating our custom HVAC family. So to create your custom HVAC family, just go to Revit home. Just go here to home. Then under home we have models here. Then we have families. So just click new. The family, click new family. And the family, click this new. When you click new, it will become a template which asking you to select the units, same like before we did on the project template. So you can select it here. Let's select the metric units. So go here on the family template, select the English. Then we want to make a HVAC family, so go to mechanical equipment. Example, we want to make for example, let make a VAV, variable air volume. So we can come here, then select mechanical equipment, ceiling based. There was a metric mechanical equipment, ceiling based. We have here metric mechanical equipment, wall based. So this ceiling based means it will be mounted on the ceiling. This wall based means it will be mounted on the wall. Or if you don't want to customize it, you can select the mechanical equipment without assigning the mounting location. So let's select the mechanical equipment without assigning. We'll go to assigning when we open this model. After clicking mechanical equipment metric, click open. So it will open like this one. Then go to when it's open this tab, reference level. We have here front. This is a front view of your model. We have this one is left. We have view 1. So let's create maybe VAV box. So you go now to create. Then you go here on the forms. On the form there is extrusion, there's a blend, resolve, safety, blend. So click solid extrusion. After clicking solid extrusion here, you can select a rectangle, or you can select a line depending on the shape of the family you want to create. For example, let's click rectangle. Then after clicking rectangle, and draw. So as you see, we are now on the left. For example, let's draw here VAV. Let's draw box here. Then hit escape. Then go to edit. Only hit escape. So when you finish editing, this one will change to extrusion. So here you can drag and setting its dimensions. For example, let's put 600. You can drag and drop. If you go to 3D view, you can see how your family is now after modeling. So here you can increase its shape and size. Just click it, and you can drag all the way left or right. So for now we have this just created the box. So let's now creating the connection. Let's create the duct connector or creating the pipe connector. So this is the front side. Select the front side, then come to create. Under connectors, you can select the duct connector. So before creating the connector, let's go back on the editing, then go to create. Let's go on the extrusion to create another extrusion here for our connector be mounted on. So we can select here, for example, draw two box. Then click OK. Go to 3D view. And drag them out. This is our connector where in which we'll this is a surface in which we'll put our duct. So then come back here, then go to create the connectors, duct connectors. So come to create again duct connectors. Then you select here, you select placement. As you remember before, there was a wall based, ceiling based. Then so if you select if you want to select a work plane. So if you select the work plane, the menu will come to pick specify work plane. Or if you want to place it on the face, just click face. Then you select it. We already created these faces. You see, as you see already these faces. So you just select one face. Let's select another one. So we have now our duct connectors. So let's customize them to define which one is inlet, which one is outlet. So just click that connector and go here and you can define its height or width. For example, let's put 500 maybe, 500. And here on the flow direction, let's put outside of the VAV, because it's supply air. It's come from outside the VAV. So you can define here. Also you can define the shape, round shape, or rectangular shape, or oval shape. So for example, let's use round shape. When you select round shape, it will change the diameter. So this is a value you put here. It's a maximum. It is a maximum diameter in which your family will create. So if we put 600, we can draw. We import this our our Revit project will only be maximum to draw up to 600 diameter. So if you put maybe 700, our maximum duct will be allowed is 700. So here you define the dimension. For example, let's put 500. Then hit apply. Then we come back to another one. This one, maybe we can leave it as rectangular. Let us leave as rectangular to see on each how does it look. So here you can define also the size of the duct, maximum size. For example, let's put maximum size 600 by 600. So this one we define define value. When you create the rectangular duct, you cannot, this family cannot exist this value which you put here, you define here. So if you go, you create the duct beyond this value, it will give you error. So let's define here the flow direction. You can select, for example, out. Let's define system, maybe return air. Click apply. So then go and save this Revit family. So go to file, click save. Put a name, maybe customize the VAV. Select the location in which you want. Also here in the option, let's put one backup. Okay, save. So now you can let's load this to the project and start drawing the ducts. Click load into project. Okay, let's save our project. So if you go to systems, you go to system tab, equipment. You can see now we have a VAV box customized. You can see it appear here. It appear here. So we can insert it to our model and starting drawing the ducts. So also you can change it location. You can change its orientation. So for example, let's put here. Also you can put as many as you want. If I select, here's the camera, the connectors in which you can start draw duct. This is we set it at 200 and go for example here 60. So as you remember before, we defined it not to reach 500. So come to draw duct. Let's go to view section. Let's go here as a section, then extend section. Open our section, view it to see how to draw, how you can draw. So when you click draw, it will let you to select which connector you want to draw. So for example, I select the supply air, which is round duct, and also flow direction is out. Connector number 2 is return air, which is 24 by 24. So let's select the supply air around 20 inches. So now we get an error. Let's see how to solve it. Says the segment is being drawn from the wrong side. The connection location we indicated. So let's see how to let's go to view. As you see now here, the connector location is backward. So if you want to draw here, you have to drag it on backward. So that's an error occur because we wanted to draw from another direction which connector is not facing. So if you select draw to the direction in which the connectors is facing, you can see now you are customized the family, and you can start routing the ducts on your customized family. So same like we did on this build family on the Revit. So that is how you can customize your own Revit family depending on your needs. Sometimes when you are doing the project, you find that there are not available Revit family or on the website which are not matching your needs. So if the family is not matching your needs, you have to create your own family. Okay, thank you. Let's have a short break now. We'll come back. Hello, Mr. Mubarak. So now we are continuing. We want to check how to customize original Revit family. Just overview how to customize the Revit family, which come in default on Revit. So for example, now we have this. For example, now we have this air handling unit vertical. For example, you want it to customize it the way you want according to your project. So you click it, then you go to click the model, then you go to edit family. So when you go to edit family, the file will open, individual file of the model will open. So over here, you can customize its parameter, or you can change the location of these connectors depending on your need. For example, you can see here, this is a pipe connector. You can if you rotate it, you can see this was an electrical connector for power. So for example, if you want to change its location, you can change it. Or if you want to add something, for example, let's change this. Let's locate this pipe connector from back side, move it to the right side, this side. Or sometimes maybe let's to change this duct, move it to down. Let's put this another side. So we can let's delete this one. Just click it, go to delete. The red X is delete. Then click this space, also click delete. So let model this air handle unit. You want to customize it and change the duct connector and put it on other side. As you can see, it was here, the front side. We want to put it on the right side. Here you can change it with textures to see how to see. So on navigation, is on front. This is the front side. Let's put it on the right side. So go to create. Then go to extrusion. First one, let's go back to our 3D model. Then right click. When you right click, go to we want to find the reference view for this model. As you can see here, we only see the one view. So we want to find the reference view in order for us to draw. So right click on any open space, then go to find referring view in the project, find in project browser, or you can click find the referring view. For example, here you can see the floor plan level, reference level, right level, left level, left elevation, right elevation, front elevation. Let's go to reference level. We open view. So it will open the view for this family, Revit family. Also we can open another views. Go finding reference views. Let's open another one, right, this left, in front. So let's open all view. So now we have V1, we have reference level, back, front, we have left, and let's go to create right, open right view. So now we have all views of this original Revit family. We want to customize it and change it. The duct connector was on the front side, so we want to move it to the back side. We want to move it to the right side. So as you see, here is a view for right. So this is electro connector, and we can delete it, no problem. You have to see clearly here. So now we are on the right view. Let's go to create tab, click tab, then go to extrusion, then select it. So here it will ask you to select which view for you to start the modeling. So that come here to select you can select rectangle, Hello, Mr. Mubarak, hold on. Hold on, I'm getting back to you soon. So now we are continuing on supply of ventilation system, mechanical ventilation system. So for now we have a supply system, exhaust system, and also we have supply system, exhaust system. You can see here. So what is a supply system? So supply mechanical ventilation supply systems uses supply outside air the space. So the fans supply the air from you can see here is a air handling unit. Air from outside is forcibly through the central supply fan, transporting through the ducts. It's forcibly to the space. So when the air entering the space, it is called positive pressure. It creates the positive pressure. When we supply air inside the place, we create positive pressure. So the part of the supplied air is moving through the building. If we have a small cracks in the building, or we have small gap on the doors and the window, the portion of the air is moving out. That process is called air infiltration. So part of the air are remaining, the another part of the air escape from the building envelope. So the systems of supplying air from outside is creating a positive pressure in the building. That is called the supply ventilation. So this type of supply and ventilation, it can be used in location. Because the air is introduced into the house at a different location. So this outdoor air may be mixed with indoor air before delivered in order to avoid cold air draft in the winter. So this is a concern when you install the supply air system. There is a concern which we need now to discuss. So this supply air does not remove the moisture from the markup air. So they may contribute to higher heating and cooling cost compared to another type which is called energy recovery system. So another problem, another concern with supply air is that supply sterilizing the house. So this system have potential to cause moisture problem in cold climate. So in cold climate, especially in winter, this supply air system will not be suitable because it can cause moisture problem. So when we come to exhaust ventilation system, in our drawing here, we remove air from the building. So there are exhaust fan here, removing air outside the building. The air is where the air is passing through the ducts from the spaces. Then it directed outside the building. So this creates a negative pressure in the building. So on the supply, the air infiltration coming from outside. see here, coming from the outside of the building through the small gaps on the window or on the door, or if the building if small cracks on the wall. So this structure, this is exhaust ventilation, mostly is usually in for example in the kitchen areas. We mostly use this exhaust ventilation system, or in bathrooms we mostly use these ventilation systems. So on the return ventilation system, basically when we supply air to the space, we need to remove the hot air. So we use a return air system. So now let's go back to Revit. So we roughly previous model here, the duct. Go to the top section, then go to the section. So now we are going to create the duct layout. For example, for we can select for this mechanical level. It's mechanical sixth floor plan. We're going to create the duct for which will supply air for this restaurant here. So select this level, then right click, go to floor plan. So this is a floor plan level 6 according to our architecture model. Floor plan of level 6. So the first step to create the duct layout is to add the diffuser. So we coming now to systems tab. We come to system tab. We select the air terminal. So when you select air terminal, here we can select the inlet size. Let's select the 20 inches, for example. Then you can place let's place one, place second, place one in the middle here, another one. Here, let's place another one here, another one here. Hit escape times. So let's go to section view and see how this diffusers arranged on the section view. So you can just let's delete this one, create again. Create the section view here. Let's go to view tab, go to section, then right click, drag up to the end of the building. Then you see this section facing the opposite direction. So you click this flip section. After that, you drag to include the area. Now we are working on this kitchen area. I mean cafeteria area. So you drag up to the cafeteria area. You drag this section here to fill the cafeteria area. After that, you click it. You right click, go to view. When you go to view, you can increase here. You can see here the crop region. You can increase the whole and increase the crop region. You can go here and you can go here on the detail and make it fine. And basically, you change how detail are displayed. So if you choose course, it will only show the lines. So go here, then click fine. After that, you can see our diffusers are down on the floor, but the diffusers should be upward between the slab and the ceiling. So we have to position them the upward. So position them. Let's go to the previous level 6, floor level 6. Then we select all. After selecting this element, now here we are selecting element including other element ducts here. So we go to filter element. We check none. Then we select terminal. We want to select only terminal. Click apply. Okay. So here we selected only air terminal. We want to position them to the ceiling level. So after selecting it, come to under properties. You can see here reference level, level 6. So you can position them according to level 6 or level 7, depend on which level you will choose. For example, if we choose here level 7, mechanical level 7, this elevation, maybe we can put it, because it needs to be down, we can put it maybe 600 millimeter. Then apply. So you see here, we are now on the required elevation. So for now, let's hide this. Let's hide this the duct that we created before. Let's hide it. If you hide element, we'll only hide this only part. So if you hide category, hide in view category, you will hide all the system. So let's hide it for a moment. Then in order to get space to work on our diffusers. So if you select one of the diffusers, you can see here there is you can create a duct. So you can come here, you can select this diffusers have round duct connector. So you see now it become a round duct. So here you can set the size. Select the size of the duct. Go to 3D view. You can see here small segment of the duct is drawn. So let's creating layout for connecting all these 6 diffusers. So for now, let's hide this. Let's hide this previous duct system. Let's hide in view. So let's hide this in order to get more space for diffusers. If you want to unhide the element, you just click here, reveal hidden element. When you click here, you can see the one with this color is all the elements which are hidden. So to unhide them, just click it, then right click, then select unhide. Then go back, close the reveal hidden. So you can see now they are back. In case if you want to put them back, you just come here, reveal hidden element. So again, let's go to section view, go to view. Let's create a connection. Can add another here. You can make a T connection. When you available, click that elbow, then click this plus button. Elbow will change to T. So also you can draw here another duct. Let's go to the top section. So let's go create another section of the duct here in the middle. Then we will put the branches to our 6 diffusers. Come again to system, ducts, select round ducts. Then select so then let's draw branches connected to our diffusers. So here let's make it small. For example, let's go again to section view to check. You can click another section view to see this side. So when you come to another section here, you can see the duct is outside the level. It's outside the ceiling level. So we need to move down this diffuser. And also this round ducts. Go to detail, make it fine. Also this one, move it upward. Go to plan view. So you can go to section view here to see each arrangement on each side. So this 20 ducts, it has 20 inches. So if you look at the space, it seems like a very big. We can select it. If you want to select this whole system, just select one duct and click tab until the whole system is marked. So here let's use maybe 10 inches. So now we can align this duct be aligned with the diffuser. Also, this diffuser need to be same size with our duct. So let's use 10 inches also. Then let's align this duct branch to connect to our diffuser. So click the duct, come to this tool here, align. Here, come down and set click the center of the diffuser, then click the center of the duct. So let's just move with this diffuser, or we can increase the size of let's move this diffuser. So let's go to another section to make this diffuser on the alignment center by another section. Let's draw another section here. Then go to section, go to view, and we can increase this crop of view. Then come here, just to find. So let's align the diffuser with the duct. Also select the diffuser and then come here to align, click align. Click the center of the first diffuser, then come to the center of the duct. Let's change this wireframe in order to see the internal lines. Then come to align tool. Click the center of the let's go to the top view. So you can see now it is aligned. We can lock this avoid the movement. Lock. So let's now go to connect this diffuser to our round duct. So click diffuser and right click on the diffuser, then draw flex duct. then connecting. Let's move it. Let's move down. Move a little bit. So let's go to second view to see why it does not connect. You can go to second section view and see. Let's create another section here. View section. Go to view. So we have to make it small down. Because the system failed to create here the elbow because the space is very small. So let's go back to top view. So now we connected this. You can see. You can see now it's connected to now we disconnected it by using the flexible ducts to connect the diffuser. So let's select other diffusers and change the size, like this one, 10 inches. Select all, then filter, and then check none, click terminals, click OK. Or you can click one, then hold Control. Then come to here and under the properties and select the inches. So here it can first connected to the big duct, so you can delete. So let's align this to this duct to another one here. Let's create another branch. Go to System, Ducts. This is the size here, inches. you can draw here. If you see the door doesn't connect, you can draw here duct, then you come to connect it. So let's align this connection with this duct. Let's align. Let us move this section first to see. Section view to see. So we can move a little bit here. Then draw flexible ducts. So, but make sure you are making the flexible duct very small in length, because flexible duct have a tendency to create a higher pressure drop. So when designing, make sure you use a small length of the flexible duct. So you can see it is now connected to the diffuser by using the flexible duct. So let's align these pipes. Go to align tool. So let check this section. This section, flip, and let's see this section. And crop this view. Then go to find. So if you cannot find the round diffuser, find the round diffuser under the system mechanical equipment, if you cannot find the round diffuser on your families, let's go to website. You go to download the family. So go to website and type price HVAC. Go in your Google, type price HVAC. Then you can select the price industries. This is in case if you don't have the round diffuser. If you don't have this round diffuser on your system, go to your browser and type price industry. So when you open it, go to products. Here you can see the product. Then click diffusers. So as you see here, there is a lot of various types of diffusers families. So this is the round diffuser, so go click it. Open your browser, then type price industry, or you can type price HVAC. After typing the price, HVAC, click the first link. Then under products, click diffusers. You open website with the various families. Then click this one round diffuser. Then go to Revit. Go to Revit here and download this button, download button. So after downloading finish, open the file on the downloads. Then extract the file. So the file you have 3 types of diffuser. The first one is exhaust, second one is return, and the third one is supply. So we'll have the 3 families for round diffuser. So go back to Revit, then come to mechanical equipment, and under the system tabs, come to mechanical equipment, then click load family. You select the location in which you downloaded your round diffuser. For example, if you work on supply system, you can click supply, then you click open. So it will upgrade the model. So if you come under the system, again mechanical equipment, under the system you come to air terminals, you will see here you have a round diffuser. You see here you have a round diffuser. So also you can insert it to your model in the starting routing ducts. So that is how to insert a round diffuser if you don't have it on your model. So after inserting the round diffuser, you can come on the floor. If it's a 6th floor or first floor, then you come to the level. You open the level and you start placing it. So, for example, you can open any level. You click go to floor plan. So you will have this floor plan. Then you come to system. You came to air terminal. Then you select here the round diffuser. You have 6 to 36 inches. So you select it. You come to place. It on your floor plan. Then after placing it, you can start draw the duct. Select the flexible duct. Then you draw. Select the flexible duct. Then you draw duct. For flexible duct. So that you come again to systems, then you can select that. And come to create view and see how it is arranged. On the ground, so you need to place it on up. I select it, and then you come to the properties and elevation from level. You can place it maybe 3 meters. So 3 meters. It is 3,000 millimeters. So it apply. So you can move this flexible duct which was connected. You can move it. So when you inserted make sure you check on the other second view to see how it is arranged. So also you can also section and see how the remaining are arranged. Just go to view, section view, you create section view, go to view, then change here to find. So you can see this one is upward. So you can see here we are working on the first floor. So just crop this. You have to see this first floor. You see that they are downward, located on down. So you need to select them upward. So the one we just did, we set it 3 meters. Selecting also, move this. Remember to move this flexible duct. So let's draw here the duct. Go to system duct. So the elevation also you can set it as 3 meters. Then you click apply. Then you come here, you do again the duct. You set elevation to the same 3 meter. You apply. Then you draw the connection. We want to draw another. We want to connect it to this middle duct. So you come again. You draw another one. Elevation. First of all, you must set the elevation must be the same with this main branch duct. So make sure the elevation are the same. Then click apply. So you can drag and connect to for this flexible duct. So if we You can delete it, then increase this size of the duct, hold and drag, or you can right click then draw duct, move up to here. So if you get an error, you have to go to section view and see maybe here the arrangement is very close. So you can see here and move it. Come to draw again. Then go back to the plan view. We were working on level 4. So go back to level 4, click the diffuser, draw duct, then connect it to the duct. So actually also this need to be the same length with all another. Just delete it and increase its length. Let's go to draw duct. Move the elevation to C. Good. So you can see now the duct is down, and you want to the diffuser which is down. So probably here it cannot connect. So you need to make alignment by moving this duct, moving upward. We have enough room here. Move it upward. And also you can move this diffuser. Then you can draw duct. And maybe here. Then you go to elevation. And draw flexible duct. So make sure you go to the section and see how it is arranged in the section view. So if the diffuser is up and duct is down, probably it cannot draw. So when you're drawing, make sure you check all views, not only just a top view. You need to come around and see how it looks on the section view. So as you can see here, we just draw layout of this duct to this room. So on the next session, we'll see how to size this duct, to size this system according to this space. So let's have a short break, like 5 minutes, then we'll continue. So if you try to draw this layout, duct layout, I think maybe you will be able to draw duct layout and connecting the duct the diffuser. So if you have just draw a small layout, we can come to see how to split duct and how to size this duct, because we just draw a layout, then we come to size this duct system. So to split the duct, you can just type SL. You can just type command SL. When you type the command SL, it will occur this icon like a knife. Then split. Select the segment with the duct. You can split it to two connected pieces. So I repeat again, on your keyboard, after drawing the duct layout and connect it with the diffuser, if you want to split the duct, for example, we want to split the duct, this segment, we want to make it two parts. So you can type SL on your keyboard. It appear this image, this icon like a knife. Then you select the length. When you hover, you see the length is changing. So you can split the duct. You see here the duct is splitted. So this is. So you can see that. So that is how to split the duct. So alternative way to use this split command product, just go to view tab, then go to user interface. You can go to keyboard shortcut, then in the search you can write split. So when you write split, it will show you here split element, the modify. You can get it and modify. Its path is under modify. The second one SL. So SL, then go to the duct. For example, this segment, select it and modify here. Let's look here for the split option. You see here we have two options: split element into separate individual, and here also we have split with gap. So we select split element. When you select it, then you can come on the duct to split. Hello, Mr. Mubarak, are we together on how to split the duct? So after you create this, just rough layout. You just create the rough layout. Then
Yes, I'm here.
you can come to keyboard and type SLO. Type SLO on your keyboard. When you type SLO, the cursor will change to a sign with a knife. Then you can come to the duct segment. Then you can split the duct. Alternative way, you select the duct segment. Just select the duct segment. Then you come to modify. Then under modify, here there is a split element, and here is a split with gap. So you select this split element. Then you come and split the duct. So now let's see how to size the duct. We just draw this layout as an example. Let's see how to size the duct. So as you remember before, we calculated the requirement of the door air for ventilation on this. Calculated the required of the door air requirement on this cave area. So we'll use that data to size the duct. So let's go and open that document. So when we did it before, we calculated the requirement of the door air for this exterior area. So we got last time we got 885 CFM. So when we come back to Revit, you can see we need 885 CFM for required of the door air supply here. So now we can see we have 3 diffusers. So we can divide 885 CFM for 3 diffusers. We get 295 diffusers CFM. So we model in our model. We have 3 diffusers. So we take total CFM, which we calculated before. As you remember, on OPR, we calculated the required CFM for so we take total 885 CFM, we divide by 3, so we get 295 CFM. So each diffuser we need to supply 295 CFM. So we go back to our model and we select diffuser. We select the diffuser here under the flow. We type 295 CFM. We go to another. We also type 295. We go to the third one, 295. So after that, we'll use a duct sizer, McQuay, to size our duct. So to get this software, just go to your browser and then type Daikin duct sizer. Typing, click this link, design software tools. Then you go down here under size and calculate ductwork. You click this one. Then it will download that size. After that, you will unzip the file. You open it. Then right click. Right click and extract all. So that will get this set up. Open. Yes, run. Then unzip. So after minimizing, let's go and open. Its file location will be under C program files, then folder called McQuay. If you go to your local disk program files, then you find a folder called design tools, McQuay, this one, then design tools, then that sizer. Here we'll have a that sizer. You open it. So when you open the next sizer, here we'll have 68 Fahrenheit air at STP, standard temperature pressure. So we can leave it at that setting. So we come here. We want to start sizing from here, going backward. So from here, we as you remember, we divided by 3. We have 295 CFM. So we come here and you type 295 CFM. So on the head loss, mostly of the designer use between value from 0.8 to 0.1. So you can see here on which value we explained it before. So here I want to show the value of who, which most of the designer use. Pleasure to use these notes so you can pass through. So you can see here the loss of pressure due to friction of air moving through the ducts, heating register, or other components. So the design friction rate is generally determined on the velocity of air in the first section of the duct. So most designer use a design friction rate somewhere between 0.08, 0.1 inch water column, 100 feet. So we'll use this value between here. So when we come back to our duct sizer, we can put 0.0, the value between 0.08 to 0.1. So when you put head loss here, automatically calculate the velocity, and it will calculate the equivalent. Here we put remember we put 295 CFM, then head loss 0.08. Automatically it show here velocity 641.8 fpm, equivalent diameter 9.2. So according to the manufacturing of the ducts, they manufacture the ducts in even number. So we don't have 9.2, so we'll choose 10 inches. So we'll choose 10 inches. So if we want to, in terms of duct size, in terms of rectangular, you can put here, example, maybe let's put 2 inches. 2 inches by 2 and until we reach this 9.2. So we can put here and see which value coming until we get the equivalent diameter matches with the equivalent diameter from our calculator. For example, 4 inches. Let's try 6 inches. So it's need for equivalent rectangle, you need 6 inches by 12 inches. So if you want to use rectangular duct, you'll use 6 inches by 12 inches. So another thing to note on using sizing the duct, rectangular ducts, you have to make sure that the aspect ratio of the rectangular duct is not more than 3:1. That means 3 is length one is height. So also here is a recommended air velocity for residence. Here is for public buildings. So you can see our duct velocity is in the required range. So when it is most important to design velocity. If the velocity is very big, it's very high, it will cause a lot of noise in our duct system. So also when you size your system, you have to look for the range of the velocity. You can see here our velocity is 6,641.8. So it is between our range, required range. For residential, you can see here it's between our range. So when we come back here, we got 10 inches. You can come here and select 10 inches. So this branch will continue 10 inches until here. So all this one will be 10 inches until we reach here. When we reach this part, we have another branches from T, which before we said, it is also 295 CFM. So this branch from this supply diffuser up to this T will have 245 CFM. But from this branch here, we'll have a total of CFM from first diffuser and second diffuser. So from this branch, we'll have 295 CFM times 2. So the FPM here will be 590, which will pass on this duct section. So we have to come back to our duct sizer, and we put here 590. So the 590 under the same head loss, each water column 100 feet, we got equivalent diameter. We got the equivalent diameter. We got our equivalent diameter 11.9. But as we say that the manufacturer does not manufacture the duct with 11.9, so we opt bigger size. We choose 12 inches. So this portion here, from here to here, will be 12 inches. We come there and selecting 12 inches. We select 12 inches. So this whole portion up to this T need to be 12 inches. So as you see here, we have a bigger size of the duct. Here we have small. So automatically Revit created a transition here, like a reducer, change the sizes. So you can see here the size decrease, and here the size big. So when we come to this another branch, you can see we have as you remember here, we have a total of 590 CFM, which is passing through this 12 inch And here we also have 295 CFM. So this branches total, we have to plus CFM coming from this branch, the total CFM coming from this branch. So for this branch, we have 295 CFM here, and here we have 590. So when we plus, we'll have a total of 885 CFM. So this portion, we come to size it again. We increase our flow velocity to 885. We put our head loss here, 885. We then put our loss 0.08 like before. So you can see here the equivalent diameter 13.9 into bigger size, even number, which is 14. So we come here and we size 4 inches. So you can see automatically Revit increases the size and form the transition. So this is how to size duct using a Macquarie duct sizer. So after sizing your ducts, press save button, save your model. Okay, I'll get to you back soon. Let's take 5 minutes break. I'll get to you back soon. Hello. So now we want to check how our duct system to check for continuity and connectivity. How to check if there is no maybe system which not connected. So when you just do any duct layout, you connect it with diffusers duct. The first method is you can move the cursor, move your mouse cursor and place on any element. For example, I can place it here. Just only move. After that, you click tab. You click tab one time, multiple time until you see the system is full selected. So when you click the tab, you can see the system is full selected. So like here I click tab button on your keyboard. On my keyboard, you can see it changes the whole system, change part to blue. So if you have a whole system there, you can select. So you can see select the whole system. So you can just check the continuity like that one. So another method, you come to analyze, then you click here, check that system. You just click this button, check that system. Then it will show you where there is no connection. So it will have, when the system will show this small message. So you just click it, and it will show you here. You can read there. Element in mechanical supply A8 are not connected in a single physical network. 2. So you can see here the downward we had some few diffusers, so we are not connected to any. We are not connected to any that system. So it tell you. So you can go here on the system browser and select this mechanical supply 8. And just review and see. Just select this mechanical supply 8. Select all members. So you now select that. You go to maybe 3D view. You can see here the members are not connected. So it tell you that element in mechanical air system 8 are not connected in a single system. So if there is any kind of error, show to you in your system. So if there is any disconnection, you can go there and fix on your system. So that was how to check the continuity of the system. Now let's go to how to create spaces and zone. Let's go back to our level, level 5. it's mechanical level 4, in which we draw our complete that layout. So basically here only we will go to connect it to air handling unit on this side. So now let's create a zone and spaces. So to create a zone and space, just click your model, select your model, then go to edit type. And it is room bounding. If it is not, it is blank, not ticket. Double room bounding by ticking it, then apply. Then hit OK. After that, go to Analyze, then click Space. So when you click Analyze and then you click Space, you can see you can move your cursor to room. So automatically Revit detect each room. So you can assign space. You can assign space on each room. So here we have WC. So you can place it manual, or you can just click here, place it automatically. So after creating the spaces, let's see how to create the zone. So you create first the space, then you create the zone. So basically, what is the zone? So a zone, it can be maybe a wool floor, or it can be one room or one building. So the zone is controlled. One zone is controlled by one thermostat to control the temperature inside that room. So for example, if you have one zone, so it will have the same characteristics of the indoor air. For example, if I select here, I create the one zone for this room and this room. If it is one zone, means if I need to set the 25-degree temperature centigrade, it can only be controlled by one thermostat. To create the space under Analyze tab, you just click space and you click zone. When you click zone, you're coming to your spaces, then you click you add zone. Example, you can see this one. It changes now to black. So basically here, after creating the space, come to zones, and you select your spaces. You can see this one is a zone. This also can be zone, or you can set the wool flow to be one zone. Well, let's delete all the spaces. So the first thing to create a zone, you come to analyze, tab, you click space. After clicking space, when you move your cursor, you can see it automatically takes, or you can click here place automatic. So it has 23 spaces created automatically. Then after creating the space, come again to zone, define HVAC zone. You click HVAC zone, and you take this one, add space. Then you select. For example, I want this room. I want these rooms to share the same characteristics. So you select that one, you select this one, and then I select this room. After that, I finish editing zone. So you can see here there's a line which link all these 3 rooms. So that means once the thermostat can control the indoor condition of this 3 zone, of these 3 spaces. So zone basically can be the wool flow. Also it can be one of the wool building, or it can be one room. You can see this one is the zone. You can add another zone and analyze. You click zone, then you click add space. You can click this one, you can add. Then finish. You can see here these 4 rooms is a one zone. So means if you maybe want, we can control the temperatures inside this room by using only one thermostat. So the meaning of the zone is a different area to have the same control of indoor air characteristics. So we can assign one zone, another zone only for cafeteria area. Also come to zone, add space, click add space, then come to your space, then click editing zone. So you can see here we have independent zone only for cafeteria area. So you can see here we created one, this is a 2, 3. We created 3 zone. So each zone can have its own control depending on our design purpose. For example, I want all these rooms to have maybe at the same time all to have the same type, the same amount of heating. So through zone you can categorize that room. So let's see how to prepare a model for load calculation and analysis. Under analyze tab, just go to here, create image model. Just click this button, create image model under energy optimization. So if you click, it will tell you that you're about to create energy model, and this may take time due to Revit will not be accessible. So it demanded too much power of your machine. So it tell you Revit may not be available. So you can click create energy model. So it will load depending on the items of your model. So you can see now it created our analytical model for the load calculation. So on the next topic we will see how to check and generate and optimize this model for the cooling loads and the required heating loads. Hello, Mr. Mubarak.
Okay, I'm here. I'm here.
Hello.
Hello, I'm here. Hello. Hello. Hello.